Hello, this is a quick accompanying video to our first session of an introduction to coding and electronics with Raspberry Pi and Arduino. I am a Raspberry Pi certified educator, which I got from the Pi Academy, the Raspberry Pi Academy, part of the Raspberry Pi Foundation. We always like to say this, like we start a journey of 1,000 miles with a single step. My name's Paul Woodhead. The company I work for is called No Worries IT. We've been IT professionals for over 20 years now, and we've been delivering training around about this sort of field for well over 10 years. So who do I think I am? It's a very, very weird, deep and philosophical question. But in this sort of context, I got my first computer in 1980. I got a Sinclair ZX80, then a ZX81, then a Commodore VIC-20, then a Commodore 64. Then I got an Amstrad PCW. Then I got an Olivetti 8086, which is the one you've got Kazim in the picture with her. And then I got access to that wonderful resource in the early 90s where you can learn all what you want at this massive library known as the internet. So this was just before the advent of Bill Gates. So who do I think I am? Part two. I've been in business since 1991. I've worked in IT since 2003. I've got numerous certifications, professional certifications, lots from Microsoft, Cisco, stuff like that, Computer Technologies Industries Association, etc., etc., etc. But I discovered open source and became an open source evangelist. I've been on numerous mentor programs. I am an avid educationalist, and I really do evangelize about open source. Also, as an organisation, because we have other instructors with us as well, we operate on what's called constructivism. So we'll let you do the work, really, which sounds like easy, but we facilitate you doing the work and we're there to help you along. So it's your own experiences, your own projects, creations that educate you. There's a famous saying by Kurt Gabrielson, which is, if you tell somebody something, you forever rob them of the opportunity to discover it for themselves. So when we have ownership of the knowledge that we get, we better understand it, we better hold on to it. It stays in your brain a lot longer. It's, neurons that fire together, wire together. So there's no better lesson, than the lesson of experience. That's why I really like the tactile kind of learning journey that we're going to go on. So you're the teacher, you know what I mean? We're the facilitators. We provide access to the resources, the expertise that we've got for when you get stuck and things like that. But essentially, this is about you educating yourselves in an environment that facilitates and provides you that nurturing environment where you can learn. So I'm going to just a little bit of a rant, but it's the travesty of ICT. So the early 90s, they started phasing out computer science because the government sort of said, no, we all need to go over and start learning ICT instead, which is using things like Microsoft Office, doing mail merge and things like that. So obviously Bill Gates was very, very, very pleased about this. So along come Windows, and he promised to put a computer with Windows in every classroom. Well, good to his word, he did do. But since then, everybody really was learning how to use Microsoft software. That's what the IT industry became, really, until quite recently. So there was a blockage in knowledge, essentially.
He's blocked the whole pipe.
Bill Gates blocked the entire pipe of computer science knowledge. So the people of my generation that grew up doing computer science, once we got to the sort of mid to late 90s, computer science stopped. So there's a gap in the development of learners, students, computer scientists coming through. So
he's blocked the whole pipe.
To address this, can't get rid of him for some reason. To address this, they came up with, some very clever people got together and decided that physical computing was the way forward, and got people to actually see computers as something that were physical again, rather than we just interact with the software. So before things on like the Commodore 64, you could plug interfaces in and connect your own devices, etc., etc., etc. So Cambridge University, there's a lot more people involved in this. This is just a brief overview. So people from Cambridge University and Broadcom Electronics got together and come up with a single board computer called the Raspberry Pi. So it was officially launched on February 29th, 2012. And some good projects started up around it, like the Manchester Raspberry Jam. Started very shortly after that, which, went to its inaugural launch with my daughter. And sort of really enthused my daughter in computer science with that as well then. So the project was led by Eben Upton, along with a team that include Rob Mullins, Jack Lang, Alan Mycroft, Pete Lomas, and Dave Braben. So Pete Lomas gave us a certificate. They're all still very, very involved in this open learning platform. So just going to briefly just say, what is a computer? From your phone to your laptop, data center, they're all the same. They're all computers. They all operate the same sort of function. Everything that you see, everything that you're doing on your computer at the minute, everything there's in RAM. So it's stored on random access memory. So, I like to equate this as the desk that you're working on, the table. So everything that you've got out on RAM. So your hard drive is the sort of filing cabinet. So the processor is the person who gets the stuff out of the filing cabinet and puts it on your desk and then puts it away again, so on and so forth. So that's a pretty basic analogy of a computer, but essentially that's all it is. It's RAM, a hard drive, and a processor. So if you've got a big computer, this is exactly the same. This is a single board computer. They've sort of got it all integrated onto one credit card size computer. So it's exactly the same principle. So as you can see here, we've got like a RAM chip. This is our CPU. And just on the underside here is where we slot an SD card, which is a solid state hard drive, so we can use that as well. So it makes it really, really affordable. So you can get these, like the boards now, for around about £50 and SD cards for under a tenner, etc. So you've got a fully functioning computer for like under 60 quid. But the best thing about the Raspberry Pi is you can connect stuff. They've got this series of pins called GPIO pins, so it's general purpose input and output pins. So you can connect all sorts of things to this. So you can program whatever devices you want on them pins. So you can create, I've said it before, like a burglar alarm, or you can create something that like opens and shuts windows, or flood defense mechanism. Whatever you can imagine, you can sort of create, because you can actually connect the parts up, and you can then write a program that makes them parts work. Because essentially when we connect stuff up, it's not particularly going to do anything. The ones of voltages it will. We need to tell the devices that we connect what to do, and we do that via computer programming or code. So you can connect all sorts, you can make really, really complicated things like this on this rail here. There's all sorts you can do, it really is. But, obviously we're going to connect some smaller stuff to start with, and then we're going to work up to bigger stuff. So this is something that I've experienced in my learning journey, because I did all the certifications, like I said, in certain fields. I became a Microsoft Certified Systems Administrator, Cisco Certified Network Associate. I had my A+, my Net+, my Linux+, and I've done all this sort of stuff. But what's weird is you tend to learn in little rungs of a ladder. And as you're an adult, you don't tend to learn in an ordered way up the rungs of the ladder. We might have bits of knowledge here and there already, but what we need to do is sort of link all them up to realise that we have no gaps in the ladder, which is very, very common in adult learning. So, we have a basic understanding, we've done the odd stressful task. We've got occasional specific tasks that we do. We'll Google it and we'll suss out to do it. And then when you do it a few times, you become proficient in it. And, for all that might be quite a high skill task up the ladder. So you're on your way to becoming proficient or an expert. You just need to fill in the gaps. So this is something from the Tech Nation report, which is the Tech North. This is the Tech North component, being as we're in the North. And this was from 2016, where there were 283,000 job vacancies with an average salary of 45,000 in 2016. And, I think all Brexit happened since then. We've lost a lot of workers. So they reckon that around about now, that's getting close to 1 million job vacancies that they just can't fill, because people aren't learning these skills, and they're certainly not learning them at the rate the technology develops. So countries like China, innovation is what's changed China. And it's innovation that we need here. We need people to start learning these skills in order for them to innovate a brighter future for all of us.